In this chapter, we're going to learn how to create a basic shader, which will help us visualize our spatial mapping data. So that basic wireframe is beautiful, but we really want to change how our world looks. And to do that, let's go to the Spatial Mapping Manager, and you'll see that the material right now it uses to render our meshes is called wireframe. Let's just select that little donut icon and do a search for blue lines on walls. This will be a new material we can use in order to revisualize our world. Now, blue lines on walls will use a shader underneath. And shaders are programs that will run on the GPU. So you can do things like modify your vertices, generate new vertices, or set the final pixel color. Now, Unity's standard shader, which it unfortunately defaults to, is very expensive to run, and it's not optimized for mobile devices such as the HoloLens. The Holo Toolkit will provide several shaders that are slightly more performant. However, if you want a unique look or feel to your application, then writing custom shaders will be able to help you achieve that, and it can also give you a major performance boost. So let's take a look at what a shader is. Go ahead and find the shaders folder, and then open up the blue lines on walls shader in Visual Studio. At the top part, we have our properties. And this will be the public properties that are exposed to our code and also to the Unity editor. And we've got our CG program, which is the program portion. We're going to be using a vert and frag shader today, which in DirectX is like a pixel shader. In our vert to frag, we're going to be storing the position of the vertices, the normal, and the world position, so that we will know exactly where a pixel is at in the world. Now, we also need to know the normal because we only want to draw blue lines on the walls. We don't want to draw it on the floor or on the ceiling, so we're going to be testing the normal of our vertices in order to see if it is one that is on the wall. So in the vert function, we're going to be getting that data. First, we will calculate where the vertex is at in our view space, and also get the normal of that vertex and convert that to world space so that we know what type of normal it is in the real world. We're also going to get the location of our vertex in the real world. So now that we have that information, we can move down to our fragment shader. And this is what's going to determine the color of each pixel that we're going to render on the screen. So here we're going to figure out where the pixel is at in the world space. And we're going to default to have that color just be black, so that if it's a ceiling or a floor, it'll just be black. And then we need to decide based on the normal if it's on a wall. Now we've got some fancy math to help us determine the thickness of our line to see if the pixel we're currently rendering falls within our blue line. And that will help us determine if that pixel is going to be a very solid blue color or slightly faded blue color or black. And that is the basics of our blue lines on wall shader. So let's go back to Unity, and we will see what this shader looks like by pressing the play button to preview it. And you'll notice that we now have blue lines on all of our wall surfaces. So if you go to the scene view, you'll see that the floor and ceiling are black, and the walls have alternating blue and black lines on them. Now, in order to play with the properties that we exposed, we can open up the material, and we can change them directly here in the editor. So you can change lines per meter, and also the line thickness with that line scale property. You can do it directly here during preview mode, so that you will be able to know what properties to use on your device. Once we're done previewing, we can go to Build Settings and press the Build button to build and deploy as usual. Now you'll want to try this out on the device, as sometimes what you see in Unity does not quite match what you're going to see on the HoloLens. So always test on the HoloLens.